All right, today we're going to look at systems of equations, which we've done before. However, the systems that we've looked at have all been linear equations. Today it's going to be a little different because the equations we have may be linear, they may be quadratic, they may be square roots, they may be rationals. So it's going to be a little bit different, right? Now, when it comes to solving these systems, just like the linear systems that we've seen before, there are a couple of different options or ways that we can work these out. And one of those ways is using our calculator, graphing. So that's what we're going to look at first. How do you solve these systems using the graphing method? Which is why I asked you guys to make sure you had a calculator. So we're going to go ahead and do the first one together here. Notice the system we're given is y equals x squared plus 4x plus 5, and y equals x squared minus 2x minus 6. We want to know what is the solution or solutions to this system. So the way we're going to find those solutions is by graphing these two equations. So go ahead and go to your calculator for me. Go to y equals, and let's graph both of these on the same graph paper or on the same screen. Now, of course, you should notice that both of these are quadratics, which means both of these graphs that we're going to get here should be U-shapes or our parabolas. All right. So whatever you get on your calculator, go ahead and sketch it for me on your paper. You should be getting two U-shapes. All right, so the graph that we're getting should look something like this right here. Those are the two U-shapes. These are the quadratics. What we're looking for is the solution, and we're going to find that solution by finding the point of intersection, which in this case is right here. This is that point of intersection. Now, the calculator will find that for you by going to second trace. We've been here before, second trace. Number, I think it's 5, intersects. Just remember, you're going to have to enter 3 times before it finds that point of intersection. And if you do all that correctly, the bottom of your screen should look like this right here. This is our solution. We're going to go ahead and write that order here down. We're just going to round each of these decimals to decimal places. All right, so that first one there should be negative 1.83, and the y value is going to be 1.03. So we are rounding these to 2 decimal places. So this is our solution to this system. In other words, this order pair will make the first equation true, but it will also make the second equation true. And that's the only order pair that's going to do that. All right, so there's the first one. Let's try another one. Let's take a look at number 3. Same idea. We got 2 equations. Both of these equations, again, happen to be quadratics. So let's go to the calculator, just like we did with the first one, and graph both of these, and let's see what happens this time. Make sure you type it in exactly like you see. Make sure you sketch me a graph of what you see on your paper. By the way, guys, this is number 3, so make sure you put me down on number 3 and not on number 2. And the graph we're getting should look something like this right here. So those are the 2 U-shapes. Now notice this is a little different from the first one we saw, because this time the 2 U-shapes, they intersect each other, but they intersect each other twice. Once right here, and then another time down here at the bottom. We need to find both of those points of intersection. So, just like you did earlier, we're going to go to second trace, number 5, enter, 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 and here's one of those intersections. It's at 1.64 and 7.23. Remember, I'm rounding these to 2 decimal places. So that's that one. But we also need to find the other one. You can use your calculator to find the other one the same way by going to second trace again, number 5, but here's the catch. Here's the catch. Make sure you move your little blinking cursor as close to this point down here as possible so that it doesn't find that same one again for you. Okay, so move your cursor a little closer to this new point that we're looking for. and then do that enter, 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 and it should give you the new ordered pair. And we're going to round that ordered pair 2 decimal places, just like we did with the first. All right, Alexander, did you find it? What's that second one? Negative, okay, we're going to round it to 2 decimal places. So negative 2.14, we round it, and then the y value was what? Negative 5.9. Okay, so there it is. Those are the 2 ordered pairs. These are the 2 solutions to this system. In other words, the first ordered pair will make both equations true. The second ordered pair will also make both of these equations true. So both of these are the solutions. This one has 2 ordered pairs, not just one. All right. Number 5, a little bit different this time. Number 5, again, we got 2 equations, but you look closely there. The first equation is a quadratic, but what do you notice about the second equation? It's linear, right? So this time we're going to be graphing a U-shape and a line. We're still going to look for the same thing, though. We're still going to look for that point of intersection. That's where the solution to this system is. All right, so go ahead and put those in, and let's see what kind of graph we get this time. We should be seeing a U-shape and a line. One's a quadratic, the other is linear. Let's not forget, what we're looking for is that point of intersection. Where do they cross? Where do they meet up? I think everybody's got their graph now, and it's looking something like this here. What do you notice about that graph, though? They don't touch. So if they don't touch, what does that mean for us as far as the solution goes? There is no solution. Very good. So this system has no solution. And the reason it has no solution is because they don't intersect. They don't cross. That's number 5. Let's go ahead and turn to the next page, number 7. A little bit different, get a little bit harder here. Number 7, we have a system, and the first equation is y equals the square root of x minus 3. And the second equation we're working with is y equals 2x plus 3. So this time we've got a square roots, and we've got a linear. So let's see what the graphs look like this time. Go ahead and graph them for me. Once you got their graphs, all we're doing is looking for the point of intersection. Where do they cross? Where do they meet up? Now remember, the square root function, that's a curve. So you should be seeing a curve, and you should also be seeing a line. That's the linear. Should look something like this right here. All right, so this is the graph we're getting. Samantha, where did those 2 graphs intersect? That is correct. That is no solution. These graphs do not meet up. Therefore, there is no solution. No answer to this. There are no ordered pairs that would make both of these equations true. All right, let's give one more try here, and then we'll try something a little different. Number 9. Number 9, the equation we're working with is y equals 4 over x minus 3 and y equals 2x minus 6. Notice one of those is what we call rational, and the other is linear. So let's get both of those in our calculator. Remember, you can type that first one in by hitting the green button, alpha, and then the y equals, so that you can get your fraction, just like we have on our handout. Okay. So it's 4 over x minus 3. Second equation is 2x minus 6. Graph them. And what we're looking for is the point of intersection. You may have one point of intersection. You may have 2 points of intersection. Maybe even 3, depending on what kind of graph we're working with. So the graph we're getting this time looks like this right here. Those 2 curves represent the rational And of course, the straight line represents the linear. So what we are looking for is the 2 points of intersection. There's 2 answers. There's one right here, and there's another one down here. That's what we're looking for. Now, I've already got one for you, and that's this one down at the bottom. That order pair is 1.59 and negative 2.83. We need to find both of them, though. So, let's find the other one. Remember, all we're doing is hit the second trace, number 5, intersection, and then enter, enter, enter. Keep in mind, guys, in order to find both of these, you may have to move your little cursor around and get it as close to that point that you're looking for as possible. Otherwise, you might end up finding the same point twice. So move that cursor around. All right, Regine, help me out. What was the other one? I gave you one of them. What was the other one? Find it.
4.41.
4.41, and the y value is? There it is, 2.83. So these are the 2 solutions to our system. Both of these ordered pairs will make both equations. All right, pretty easy, right? Not too bad. Now, there are some drawbacks to using the calculator. One of them is, what if you don't have a calculator at home? What if I give you homework? Then what? Then how are you going to do it? Well, luckily we got a backup plan here. And if we don't have a calculator, well, we can always do things algebraically. Like back in the old days when they didn't have all these fancy calculators. And the way that works is by setting the 2 functions or the equations equal to one another. So just to give you an example here, if you look at number 9 that we just got through doing, we could work that same problem algebraically simply by taking the 2 equations and setting them equal to each other. So for example, we would end up with 2x minus 6 is equal to 4 over x minus 3. All it is the 2 equations, the 2 functions, set equal to each other. And then from here, guess what? That right there is the same thing you guys did for me yesterday. This is where we took the equation, got it equal to 0, and solved it. Now the only difference is, after we solve it, we still got to figure out what the y value is, because that would only give us the x. So we still have to go in there and figure out what y is. But I'll show you how that works in a minute. Okay? We're going to work plenty of examples, so I'm not going to worry about finishing that up. Let's go on. Right here, again, it's just telling us what exactly we're doing. All we're doing is taking the 2 equations, in this case, these 2, setting them equal to each other, like this right here. Once you got them equal to each other, it's a matter of getting it equal to 0, just like we did yesterday, getting it in this form called the standard form. And then from there, we can either use the factoring method or the quadratic formula, which is what we used yesterday, the quadratic formula, to come up with our solutions. But as I mentioned, we're only going to find the x values using the quadratic formula. You'll still have to go in there and find the y values by plugging them in. And I'll show you how that works here with the next example. All right, so let's go ahead and do that. Let's see how this works. Let's see, how do you solve these algebraically? So here's the first one, number 12. First thing they told us to do is take the 2 equations, set them equal to each other. So what we're going to do is rewrite this as 2x plus 1 equals x squared plus 3x minus 5. First step, the easiest step. Just set them equal to each other. From here, it's what we did yesterday. It's a matter of getting this thing equal to 0, which means I'm going to have to move the 2x to the right side, move the 1 to the right side. This way, it's all equal to a 0. So let's go ahead and do that. The x squared is going to stay an x squared. That's not going to change. But remember, we're moving the 2x to the other side, and we're doing that by subtracting it from the 3x. So in other words, 3x's minus these 2x's over here would leave us with how many x's? 1x. So 3x's minus 2x's is 1x. But we're also going to subtract this 1 that I have over here. So we're going to have negative 5 minus a 1. What's a negative 5 minus a 1? Negative 6. So now we have 0 is equal to x squared plus 1x minus 6. Now, from here, just like we did yesterday, we use quadratic formula. And that is x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. Now, we can use quadratic formula, but it also said that we can use factor. But there's also an easier way to do this. Does anybody remember an easier way to solve a quadratic without having to do all that work of quadratic formula and factoring? Is there a way we can use the calculator? Graphing. What exactly are we looking for in the graph? The zeros or the x-intercepts. All right, so I'm going to let you take a shortcut here. There's going to be plenty of work today. And instead of using the quadratic formula or the factoring method, we're going to cheat a little bit here. We're going to use the graphing method. So what I need you guys to do is go to your calculators, go to y equals, and let's graph x squared plus 1x minus 6. We're going to find the solutions by looking at this graph. Remember, what we're looking for in that graph are the x-intercepts. What are the x-intercepts? Look at the graph. What are the x-intercepts? All right, what are they? Positive 2 and negative 3. Y'all double check that one. Does that look right, Samantha? Are those the two x-intercepts? Negative 3 and positive 2? All right, so we've just found the x values, 2 and negative 3. But remember, the answers we're looking for are ordered pairs. This is not an ordered pair, guys. All we did was find the x values. We still need to figure out what the y values are. So what I'm going to do is I'm going to start right here with this 2 here. I want to know what's the y value when the x value is a 2. How are we going to figure that out? Very easy. We're going to take this 2, and we're just going to go back and substitute it in to either the first equation or into the second equation, whichever looks easier for you to work. It doesn't matter. So the question is, what looks easier to work? The first equation or the second equation? Second. So let's use the second one. All we're going to do is replace the x with the 2. This way we can figure out what the y value is. So just throw that into your calculator and see what you get. 2 times 2 plus 1. What do you get? 2 times 2 plus 1. 5. So now I know what the y value is when the x value is 2. So let me write that as an ordered pair. That ordered pair is going to be 2, 5. There's one of my answers. There's one of my solutions. 2, 5. Let me find the other ordered pair. Negative 3. We're going to do the same thing again. This time we're going to plug in a negative 3 for that x. And we're going to see what the y value is this time. So again, go to your calculator and let's do 2 times negative 3 plus 1. And what do we get this time? Negative 5. So now I know what the y value is when the x value is a negative 3. Therefore, I end up with the ordered pair, negative 3, negative 5. So there's my 2 solutions. These 2 ordered pairs are what's going to make both equations over here true. A little more work today than we had yesterday. Now we got to find the y values also, not just the x's. Okay, let's try another one. Let's try number 14. Number 14, again, we're going to take the 2 equations, set them equal to each other. Just like that. Now that I have the 2 equations equal to each other, now I'm going to get it equal to 0 so that I can solve my quadratic. So we're going to move the minus 5x and the minus 7 over to the other side. X squared is fine the way it is. I'm going to start by moving my negative 5x to the other side. And we're going to do that by adding it to this negative 3x over here. So this negative 3x plus the 5x would give us how many? negative 3 plus 5. 2. Positive 2x. Now let me add the 7 with the negative 6. So negative 6 plus 7 would give us a positive 1. So now I've got this quadratic equal to 0. All I did was move my 5x and move my 7 to the other side. And we did that by adding both of those to the other side. Alright, so now I've got the quadratic. Now I need to find out what are the solutions to this quadratic. So we can either factor it, we can use quadratic formula, or we can take the easy way out and just graph it and find the x-intercepts like we did on the last. So let's go ahead and do that. Let's graph it. Let's find the x-intercepts. Let's see what we get this time. Alright, what do we get for the x-intercepts? Eric, you got x-intercepts? Almost. Negative 1. What else? That's it? Alright, so there's only one x-intercept. That's even better for us. Less work for us. Okay, so there's only one x-intercept and it's negative 1. Which means I only have to take that negative 1 and plug it in. So let's go ahead and do that. We're going to take the negative 1 and we're going to plug it in either to the first equation or into the second equation. Whatever looks easier for you. Which one looks easier? Second? Alright, then we'll use the second one. Remember, all we're doing is taking out the x, putting in that negative 1, and seeing what we get here. So negative 5 times negative 1 minus 7. What was that? Negative 2. So I can write this as an ordered pair now. The x was a negative 1, and the y value was a negative 2. Therefore, my solution is the ordered pair negative 1, negative 2. It's the only one that makes both of these true. That's it. Okay, going on to 16. It'll get a little tougher here. Number 16, we got y is equal to the square root of 2x plus 5. And the other equation is y equals negative 2x plus 7. We're going to start off by doing the same thing. We're going to take the two equations, and we're just going to set them equal to each other, just like this. Now, we saw something like this yesterday on the assignment. Anybody remember how we got rid of the square root? You multiply it by itself or you square it. That's exactly right. We're going to come over here, and we're going to have to square both sides of the equation. Now remember, when we squared this, you have to be real careful because you're going to have to use some FOIL method. So we're going to take negative 2x plus 7 and multiply it by itself. So it requires a little FOIL here. So here we go with FOIL. Negative 2x times negative 2x gives us a positive 4x squared. Negative 2x times 7 gives us a negative 14x. 7 times negative 2x is negative 14x. And 7 times 7 is 49. Mm-hmm. Go ahead and simplify that for me, guys. Go ahead and combine the like terms. Alright, so we can combine these terms right in the middle. We're going to end up with 4x squared minus 28x plus 49. Now remember, all we've done is squared the left side of the equation. We still have to come over and square the right side of the equation. So what do you get when you square the square root of 2x plus 5? That's right, 2x plus 5, same thing. The square root and the square cancel each other out. As you can see, it is a quadratic. What we need to do is get it equal to 0 so that we can graph this thing and see what we get. So what I'm going to do is I'm going to move this 2x right here over to the other side. And I'm going to do that by subtracting. So I'm going to take negative 28x minus 2x, and that's going to give me a negative 30x. I'm also going to subtract the 5 from the 49. So 49 minus 5 would give us a 44. So now I've got the quadratic. It's equal to 0. Now I need to figure out what are my x's. So we can solve this quadratic either by quadratic formula, by factoring, or we can just graph it and see what the x-intercepts are. That'll work just as well. And I believe there's 2 x-intercepts on this. So we need to find both of those x-intercepts. So graph that quadratic, 4x squared minus 30x equals 44. And let's see if we find it. All right, what is it? What are the x-intercepts? 2, that's one of them, and 5.5. Very good. 2 and 5.5. 5.5. Now, what we found here is the x's, but we're looking for ordered pairs. So we still need to figure out what the y values are. So we're going to start with the 2. We're going to take this 2, and we're going to come over here and plug it in for one of these x's. Remember, it's your choice. You can use the first one or the second one. I'm going to go ahead and use the second one. It just looks a little easier for me. We're going to see what happens here. So negative 2 times 2 plus 7. What would you get if you did negative 2 times 2 plus 7? Nope. It's negative 2. Negative 2.
Oh.
3. Positive or negative 3? Positive 3. Which means we're going to end up with the order pair 2, 3. 2 is the x, 3 is the y. So that's one of our solutions. That's one order pair that's going to make both equations true. Let's find the other, 5.5. Let's take that 5.5. Let's plug it into the same equation, see what happens this time. So negative 2 times 5.5 plus 7 would give us a what? Negative what? Negative 4. Negative, which means we're going to end up with the order pair 5.5 and negative 4. So this would be the other solution. However, guys, on this one, we're going to run into a problem here. And the problem is this answer that I have right here. Something's wrong with it. Anybody spot it? Well, it is a decimal, but that's not exactly why we have a problem. Remember, I'm saying that these are solutions. In other words, if I plug these numbers in for the x and the y, I should end up with a true statement. Something wrong with this? Tell you what, let's plug in that so you can see. Let's plug it into the first equation. Remember, the y value, we just figured out that was a negative 4. The x value, we said that was 5.5. Now, I should get a true statement. The left side of the equation should match up with the right side of the equation. So if that one happens here, if I take the square roots of 2 times 5.5 plus 5, is my answer going to be a negative 4 here? No. So this ordered pair that we found here, it's not going to work. It's what we call that extraneous solution. Even though we didn't mess anything up, we didn't make any mistakes here, when I go back and plug it in, it doesn't work out. Therefore, it's an extraneous solution. So the only answer, or the only ordered pair that makes both of these true, is the ordered pair 2, 3. That's the only one that's going to work for us. So we got to be real careful, especially when it comes to these square roots here. Got to double check those. All right, we're going to do one more, and I'm going to have you guys try some on your own. So let's take a look at number 18. Number 18, we're going to start off by making the two equations equal to each other. There it is. Both equations equal to each other. Now we saw this also yesterday. Anybody remember what we did to solve these? Cross multiply. So we're going to multiply the 2 with the x plus 3. And then what we'll do is we'll multiply the 1 times the x minus 1. So all we're doing is cross multiply, which means we're going to end up with 2x plus 6 and x minus 1. Now, before I go any further, y'all take a look at the equation I have right there. 2x plus 6 is equal to x minus 1. That's a little different from the ones that we've seen so far. Anybody recognize what's different about it? It's linear. There's no x squared. Okay? Which is better for us because all we got to do is solve for x. There's only going to be one number here, one x. So let's find out what that x is. I'm going to start by moving this x over here to the other side. We're going to subtract it. So 2x's minus 1x gives me a 1x. So now I have x plus 6 is equal to a negative 1. Trying to get x by itself, so the next thing I'm going to do is subtract 6. So a negative 1 minus 6 would end up giving me a negative 7. So my x value is negative 7. And there's only one because it's linear, not a quadratic. So now what I need to do is I need to figure out what the y value is. So just like we did with all the others, we're going to take that negative 7 and we're simply just going to plug it in from one of the x's. I'm going to go ahead and use the first equation. All I did was take out x, replace it with a negative 7. So what is a negative 7 plus 3? Negative 4. Therefore, a y value is negative 1/4. Or if you prefer, you can also write that as a decimal. And that decimal would be negative 0.25. Which means we end up with the ordered pair negative 7, negative 2.5. So this is the ordered pair that's going to make both equations true. And it's the only ordered pair that makes both equations true. So this is how we solve systems that are not necessarily both linear. Okay. All right, I'm going to give you some to try on your own.